So I wanted to do a quick demonstration of how the control transformer works inside this altitude indicator. Up on the scope is a yellow waveform that is the AC power signal that would normally be powering the altitude indicator. There's also a pink waveform that is the output of the control transformer. I have the servo power and the servo amp power disconnected, so it won't try to fight me as I manually adjust things. But right now I have the altitude set for 0, and I have the error from the control transformer nulled out. So I'm going to go ahead and perturb this a little bit. And you see as I turn the altitude increasing, it no longer agrees with the control input from my digital to synchro board. And now that error signal coming out of the control transformer is in phase with the power supply there, the yellow, and it's also increasing. I can turn it the other way. Normally the servo motor would do this, but it's disconnected. But I can turn it the other way and try to null that error, and it pretty much goes back to 0. One of the other interesting things is that if I turn this the other direction, maybe about 1,000 feet, it's now showing the same magnitude as error as when I went the other direction 1,000 feet. But the pink waveform is 180 degrees out of phase with the yellow power supply waveform. So in this way, the control transformer indicates both the magnitude of the error and the sign of the error. Another cool thing is that, in a more modern system, you'd use a potentiometer or an encoder to sense the position of the readout. But you'd still have to have a digital circuit there that would compute the difference between the expected, the commanded position and the actual position. The output of the control transformer is basically that difference signal all already done. So it's doing the math in the analog domain using the control input angle and then the actual shaft angle on the control transformer. Anyway, that's a brief look at the control transformer inside this altitude indicator.